to find the conjugate complex of the complex number 1 by 1 plus I. Now in order to find the conjugate complex, first we have to convert this into A plus IB form. In order to convert this into A plus IB form, we have to rationalize. So we'll rationalize the denominator. Its rationalizing factor is 1 minus I. So we'll multiply and divide the given complex number by 1 minus I. So 1 into 1 minus I is 1 minus I by 1 plus. We know that I square is minus 1. So this will become plus 1. So the given complex number is nothing but 1 by 2 times of 1 minus I. Now, the conjugate complex of this number is nothing but 1 by 2 times of 1 plus I, which can be written as 1 by 2 times of 1 plus I. Again, if I further rationalize this by 1 minus I into 1 minus I, then this will be half of 1 plus 1 by 1 minus I, which can be written as half into 2 by 1 minus I. So the required answer is 1 by 1 minus I, which is nothing but option A. It is given that A and B are mutually exclusive events and we have to find probability of A plus B, that is nothing but probability of A union B. Now we know that probability of A plus B is nothing but P of A plus P of B minus P of A intersection B. Now as A and B are mutually exclusive, this intersection will be always 0. So the required answer is P of A plus P of B, which is nothing but option B.
This transform of L of S is, here we know sin AT is equals to A by C. Cos AT, the Laplace transform is S by S square plus A square. So T cos AT is nothing but minus D by DS S by S square plus A square. That is S square plus A square whole square, S square A square minus S into 2S, that is 2S square. So minus S square plus A square, S square plus A square whole square. So if we take minus outside, S square minus A square by S square plus A square whole square. That is option C is correct. Of expectation of x is. Suppose here assume expectation of x is k, which is a constant. It is going to be a mean value. So expectation of a constant is nothing but a constant, because it is the expectation is nothing but a linear variable. So k is nothing but expectation of x. That is option B is correct.
It is given that from a pack of cards, 2 cards are drawn at random. Now we have to find the probability that both the cards will be king if the first card is not replaced. Now we know that there will be 4 kings out of 52 cards. So in the first pick, what is the probability? Out of total 52, we are taking 1 card, so 52C1. And what is the probability that it is a king? There are 1 chance out of 4, 4C1. So which is nothing but 4 by 52. This is in the first pick. But in the second pick, what is he saying? The card is not replaced. If the card is not replaced, there will be only 51 cards here and 3 kings, because already we have taken 1 king. So what is the probability? The next probability will be 3 by 51, which is nothing but 1 by 221. That is option D.
Transmission parameters of the network are A, B, C, D respectively. The network is said to be reciprocal if and only if. Here A, D, B, C. C, A, B, C, D. So this is the T network. From this, the reciprocal condition is AD minus BC equals to 1, whereas symmetric condition is A equals to D. That is, this is for reciprocal. This is for symmetrical. That is, option B is correct. Characteristics of an element is shown in figure. The element is. See, the characteristics which are shown in the quadrant 1 as well as quadrant 3 are not equal. Hence, the element is going to be a non-linear. So, the element is going to be active or passive is going to be decided by the V by I ratio. That is, if V by I ratio is less than 0, that is, the element is going to be active. If not, that is, if the ratio is greater than 0, it is going to be a passive. So from this one, this is minus V minus I. So V by I ratio is always positive, hence the element is going to be passive, as well as it is non-linear element and the unilateral. That is, option D is correct. Across the terminals A and B is, here voltage across the parallel elements is going to be equal. That is, VAB is nothing but a 5 volts here, because the 5 volts is across the current sources also. So option B is correct. The below given circuits, if V1 is equals to V2, both circuits are possible, hence option A is correct. Because in circuit B, this is V1 and this is V2. Whatever may be the V2, this circuit is going to be possible. But in case of circuit A, if V1 and V2 are not equal, circuit A is not going to be possible. But the case given in the question is V1 is equals to V2, hence both circuits are possible. That is, option A is correct. Below given circuit, find the effective resistance between the terminals A and B. So V is equals to, that is, VAB is equals to I by 3 R plus I by 6 into R, I by 3 into R. So 2I by 3 I by 6 into R, which is 6, 4I and I into R. So VAB by I is nothing but RAB, which is equals to 5 by 6 R. That is, option B is correct. It has the following specifications. That is, VIH min, VIL max, VOH min and VOL max as given in the question itself. We have to find out the respective noise margins of the logic family for the logic high as well as the logic 0. See, we know the logic levels can be represented in the block diagram as in the boxes. This is VOL max. This is VOH min. This is VIL max. This is VIH min. That is, here this one and this one. These differences are noise margins. This is nothing but noise margin in the logic high level. That is, VOH min is 4.8 volts minus VIH min is 3.9 volts. That is 0.9 volts. This is noise margin in case of low level. That is, VIL max minus VOL max. That is 0.8 minus 0.2, that is 0.6 volts. That is, option A is correct. Open circuit works as, here if we apply a KCL at node A, I1 plus IF equals to 0. Here V0 is nothing but IF minus IF into RF. So here IF is equals to minus I1, that is I1 into RF. So I1 is decided by IS. Hence, input parameter is current and output parameter is voltage. Hence, it is nothing but current to voltage converter, that is